Hi everyone, welcome back. In this video we will see highest response ratio next algorithm. In short, we can say it as HRRN algorithm. Guys, this algorithm is the most optimal scheduling algorithm and it will become under non-preemptive mode. Each and every algorithm what we have discussed so far will be considering either arrival times or bus times, like that we have seen, right? But coming to highest response ratio next algorithm, here the criteria what we are following is response ratio next. Because of the criteria what we are following like response ratio next, it is yielding and it is defining as most optimal scheduling algorithm. Okay, how means generally observe, if you take any kind of algorithm like SJF, it is majorly concentrating on the processes which are having shortest burst time among all the processes will give the priority. Can you think what about the processes which are having the largest burst time and waiting since long time? That is not considered by the SJF. And it may lead to starvation also, right? If any new process which is coming with shortest burst time, always the largest burst time will becomes under starvation. Coming to another kind of algorithm, what we have seen so far, LJF, largest job first, means it is going to concentrate on the process whose burst time is very large. For those processes, it is going to give priority. Again, here the problem is also a kind of starvation and it will be waiting since a long time. Means for the process which are waiting since a long time, what will happen? For that, the solution will be highest response ratio next. Right? Here, the major parameter we have to calculate, that parameter is response ratio parameter. So based on this response ratio, we can able to reduce the waiting time of the processes. Means we can give a process which is waiting since long time can also give the priority. How means that we'll see with this particular example. Okay, fine. So generally, if I draw the Gantt chart for you, Gantt chart, it is going to start with 0 initially. What are the process which has arrived with 0 arrival time? Only one process with 0 arrival time, that is process P1. Good. And as it is non-preemptive, once it's got the CPU, it will execute its complete time. So burst time is 3, so it will take the 3 units of CPU and complete by 3. Next, by the time of completing 3 units, only P2 is available. So that is arrived at the time interval of 2. So as only one process available, I will give chance to P2 and give the burst time as 6. Yes. Then it has done its task by 9 units of time. As you done with 9 units of time, what are the process that came before the 9 units of time? Process 3, process 4 and the process 5. Now, if you apply SJF algorithm, you are going to give the chance to P5. If you are going to use largest job first, you are going to give the chance to process 4, right? So, because of giving like that, the shorter process or the longer process in LJF might be in starvation state. Right? Here, in this HRRN algorithm, we have to minimize the waiting time of the process also. We have to consider the waiting time of the process. How we are going to consider means by calculating response ratio. Response ratio means simply what is the waiting time the process done so far plus burst time by burst time. So if you observe this one, right, as the waiting time is increasing, numerical value is increases. Am I right or not? Right? So it will give chance to the process whose waiting time is more, and also it will consider burst time also. So you have to calculate the response time for all the process, and you have to give chance to the process whose response time is more. As response time is more, can I say that whose waiting time might be more? Yes, definitely. Right? So now, by the time of 9 units completion, we are left with 3 processes, P3, P4 and P5. Right? Now, you have to select the best one. Which one will select the best one? By calculating response ratio. Right? I am trying to calculate response ratio for process 3. Right? To calculate the response ratio for process 3, what is the formula you have to do? Waiting time of the process so far. Right? For the first one, I am trying to define waiting time of the process 3 so far plus burst time of process 3 by burst time of process 3. Now calculate it. What is the waiting time of the process so far did? Process 3 is arrived at 4 units of time. Now, what is the time? 9. So, waiting time of the process 3 so far is done 5 units plus what is the burst time of the process? 4 by 4, which is 9 by 4, around 2.25 units is the response ratio. Similarly, you have to calculate response ratio of 4, means whatever the process which are under the competition for running state, you have to calculate for them response ratio. What is the waiting time for process P3? Arrival time is 6 and current time is 9, so that is 3 plus 5 by 5, which means 8 by 5, which I can write as 1.6 units. Calculated for response ratio of process 5, arrival time is 8 and present time is 9, that is difference is 1. 1 plus 2 by 2, which is 3 by 2. I can say it as 1.5 units. Now observe guys clearly, as waiting time is increasing from process 5 to process 3, you are getting more numerator value, which leads to more response time. So we can say that this particular process 3 is in waiting since long time among all the processes. So as the R3 process having the more response time, I will give chance to process 3. What is the process 3 burst time? 4, and it will done by 30 minutes of time. Good. Now by the completion of 13 units of time, what are the process having in the ready state? P4 and P5. Now which one will give the chance? Again you have to calculate response ratio, right? Response ratio of 4 and response ratio of 5. What is response ratio of 4? So response ratio of 4 will be, what is the arrival time? 4. And what is the present time? 13. So waiting time is what? 13 minus 6, that is 7 plus 5 by 5, which is equal to 12 by 5, that is 2.4 units of time. And what is the response ratio of 5? Waiting time of the process. What is waiting time of the process? Arrival time is 8 and the present time is 13. So which means 13 minus 8 is 5 plus 2 by 2, that is 7 by 2, which I can say that 3.5 units of time. See, this particular situation of the R response ratio of process 5, even waiting time is very less, difference between the process 4 and the 5, burst time is less here. That's why it got here more what I can say, units of time, because the denominator you are using the burst time, right? So as you got this more burst time, you have to give chance to that particular process. So you will give the chance to P5. P5 allocated for 2 units of time, that will be 15. Then given chance to final one P4 for 5 units of time, then it will be 20. It will be 20, right? So this is the way you can able to work with the highest response ratio next algorithm, right? So in short, if I say generally between SJF and HRRN algorithms, SJF is going to allocate the process which is having less burst time among all the processes. Whereas coming to HRRN, it is going to allocate the next process which is having the highest response ratio next, right? So that is the reason we can say the advantage of this particular algorithm is it is going to favor to the longer process, In other words, if I say it is going to favors not only to the shorter process, but also to the longer process. Am I right or not? Right? Yes. That is the advantage of HRRN algorithm. Hope you understood this video clearly.